Galikoski from the DGRTD.
Good morning. Good morning.
Do you want to manage your presentation? Because I have a few slides.
Yes, I have a few slides.
Yeah, you just yeah.
Okay. Yes, so good morning again. So it is a pleasure for me to be here. I hope the microphone is switched on also for the online participants. And yes, indeed, my presentation is well, just to give a bit more perspective on the side of policies connected to the topic of bio-based materials and especially bio-based plastics. So this is the topic that the project was developing, and we're of course very happy to see this meeting and the final results that will be shown today. And of course there will be a follow-up, I'm sure. So this is not the end of this story. So, but just to give a bit of a background and some further steps. So just some definitions that we need to make about the bio-based and the biodegradable and the the definition of plastics in general. So this is of course very well known to you, but just to say that this is based on the regulations that are being developed, and many of them have been adopted recently. The packaging regulation, for instance, and the single-use plastics, of course. So many of them have been adopted, and well, of course, we don't have time now to go into detail of this now. But to say that this development on the policy side about the bio-based plastics and bio-based products in general is supported also from the research perspective and in the Horizon Europe framework program. We have the area called bio-based innovation systems that is acting in synergy together with CBE programming, and this includes the topics of use of biomass towards bio-based materials in general. But there is also cluster 4 in which looks on the development of industrial competitiveness and strategic autonomy and industrial innovation ecosystem. So this is also another part of the program that is also linked to this topic of substitution of more sustainable materials and not bio-based materials, but because this is going to be covered in the cluster 6, but still there is a connection between these two elements. Just to say that recently communication on advanced materials was adopted, and this is supported under cluster 4, whereas for the new development in cluster 6 to highlight the communication on biotechnology and biomanufacturing, which is also important in this context. It is not mentioned in the presentation later, but certainly biotechnology is an important element in biomanufacturing to be kept in mind, because there are many solutions that can also go towards new materials from biotechnology. And of course, the circular bio-based zero partnership. So this is of course the partnership that supported the project. So I will not spend too much time on this, but we are in good hands to learn more about this if needed. So and a few examples of this project. So from all these programs. Also importantly, what is listed here is not only the technological development of new materials, but also social innovation. So how to involve society in this transition, and there are also projects and topics on social innovation, and especially when you look on packaging solutions, for instance, food system, how to collect, how to avoid waste in the first place, and also the initiatives such as circular cities and regions initiative is active there. There are many activities that support this transition in different elements of this quite complex ecosystem. So this is just a summary of some actions. And in general, the areas that are supported here is, as I said, the replacement of fossil-intensive resources, then the contribution to climate neutrality. This is, of course, the overarching ambition. We cannot forget biodiversity. This was very nicely shown in the film also, the turtles in the sea. So this is important. Of course, environmental protection. As I said, the potential of biotechnology, but also the digital solutions. So artificial intelligence is a very hot topic, if I can say, on this, how this digital transition can also support better ways of developing new materials, but also the social transition and involvement of society. And of course, involvement and inclusiveness in this process, all producers, especially farmers, but also policy actors, governments. Also, this is really a collective effort, and it's very ambitious, of course, looking also on new potential of jobs and especially primary production sector, very much important in this process. So in general, sustainability, resilience, and inclusion are these keywords that the program supported by the framework program in bio-based innovation is aiming for. Just about some of the policies that were already mentioned. So the single-use plastics directive, REACH, packaging waste regulation on fertilizing products, on sustainable finance, policy on bio-based, biodegradable and compostable plastics, and sustainable carbon cycle. So as you can see, the landscape is quite complex in this area. And just a few words about some of these policies from the point of view of research innovation needs. So for the single-use plastic directive, the criteria and standards for biodegradability in marine environment is one area that is very much connected to the topic of Glaukos project, of course. Then in terms of REACH, demonstration of biodegradability and degradation under environmental conditions is also included. Packaging requirements in the packaging waste regulation, on recyclability, design, collection, sorting, and recycling, and compostability. So these aspects are included here, and these are the needs of new projects that can be supported to develop these criteria. In terms of regulation on fertilizing products, also the testing methods, for instance, mulch films in biodegradable natural soil conditions and aquatic environments in different conditions across the EU. So this is another piece of this puzzle. When we look on the policy on bio-based, biodegradable and compostable plastics, there is a provision that the Commission will promote research and innovation with an aim to design circular bio-based plastics that are safe and sustainable by design. So this is another keyword, the communication on safe and sustainable by design is applicable here. And to allow, by doing so, reusability, recyclability, and biodegradability of these materials. Then, of course, this is also an international challenge. The accumulation of plastics in the environment is a global challenge. So international cooperation on plastic pollution, addressing the famous islands of plastics accumulating in the seas globally, and so exchange of best practice and promotion of best cooperation on technical level and scientific cooperation. Sustainable carbon cycle communication, which is important because it includes an ambition to achieve 20% of bio-based chemicals use So this is also including also the integrated EU bioeconomy land use assessment. Just to finish my presentation, the last point about some further research innovation perspectives. So what would be the next areas to be supported? So again, circularity of bio-based materials, how to improve the lifetimes of bio-based products to prolong their life and to keep them more in the use and to reduce their environmental impact. Contribution to carbon removal, so approaches in carbon farming, for instance, in this area. Measurement of bio-based the content of bio-based products. This actually was also included in the communication on biotechnology and biomanufacturing. Improvement of methodology to measure bio-based content in bio-based products, because this is currently lacking. Digitalization again, so the digital approaches and artificial intelligence, information monitoring, tracing, social acceptance, so all these issues connected with social innovation. And again, environmental performances of products and whole industrial bio-based value chains. So this is a very broad topic, of course, but it remains very much important and will be supported in the next framework program. By the way, now we are in the process of developing work program for 2025 in Horizon Europe, and also in CBE programming. This process is ongoing. So new calls can be expected in next year actually. So later this year or early next year, new calls including some of these topics may be expected. Thank you very much.
Thank you.
And this is exactly why we are here, also to provide recommendation for future calls, what we have learned, also what was not easy, and what are our ideas and suggestions. So we will start with our partners. So we will start with Nick, and then the partners will come one by one without the presentation.
Okay, thank you. So good morning also from my side. I'm Professor Nick Geerks. I'm from the Research Center Jülich. And so we have the privilege, I can say, to be at both the start and the end of the process of the Glaukos concept. So here on the start, I hope this works, yes. So what a challenge we had at the beginning is especially we focus on this polymer building block, itaconic acid. This was originally a German product. So it was a European product already in the 50s, established by Pfizer. By now, all production is in Asia. And one of the reasons for that is that the microbe used to make this bio-based building block was considered unsafe. It's an animal pathogen. And so we asked, okay, how can we bring this back to Europe? How can we make it more sustainable and at the same time also safer so that we can have a good European production process? And so one issue with this current microorganism that is used to produce this itaconic acid, you see it there, it's a filamentous fungus. So it's very difficult to handle. It's very tricky to culture because it has this very difficult morphology to work with. And they also cope quite poorly with impure substrates. And this is, of course, an issue when you want to work on industrial side streams, which typically are not completely pure. And so the solution we came up with is to use a completely new organism. So we focus on an organism called Astilabomyces to produce itaconic acid. This is a yeast-like organism, so it's much easier to work with. It's much easier to culture, and it's also safer. So this is not an animal pathogen, and actually you can eat it. So the fruiting bodies of this fungus are edible, and you can buy them as a delicacy, especially in Mexico. It's used a lot. So it's called huitlacoche, for those of you that are interested. And so this is really great. It's a safer organism. What's also very nice in the terms of the technical process is that it's insensitive to medium impurities. So we can start thinking about working with these crude substrates like molasses, which contain impurities, and this organism is much easier or better to deal with this. Now, so what we did in the project and to make this work is that we have to engineer this organism to produce at maximum efficiency. So this is just a matter of genetic engineering of the organism to get the most product per gram of substrate out. And then we also need to train it, tailor it for the use of these industrial side streams. So this can be, on the one hand, molasses, which contains a lot of sugar, but also crude glycerol, which does not contain sugar, so it's completely different organism. And so we worked on strain engineering, on characterization, on the physiology of the organism to make that work. And then we also have this morphology engineered strain, so that it's completely yeast-like in its growth. It's easy to stir, to pump, to work with. And that then makes it very easy for our partners at Biobase Europe to scale up this process. Yeah, and so this is what we did on the microbe, on making the process possible in the first place. So if I can just wrap up this part by recommendations for future research, I think it's becoming more and more important now, also with geopolitical developments as well as environmental and economic aspects, to focus on regional renewable resources. So I think this is very important moving forward, that we establish these biotechnological processes with that in mind. In the context of polymer production, I think it's also important to know that if you have a biological chemical as a building block, then it's almost automatically also more benign in its polymer application. So a biochemical makes for a better biodegradable polymer. And what's nice, when we have this food-reliable process, this is a kind of platform that we can build on to explore other value-added products besides itaconic acid. And so we can then also make a broader economic impact. So with that, I think I can wrap up the microbial parts and hand over to Sophie for the scale-up.
Okay. So indeed, I will talk about the feedstock and also about upscaling. As Nick mentioned, we get the strain from Jülich and we perform the upscaling of the fermentation process. Of course, when we are upscaling, we also need huge amount of feedstock to work together with. So at the beginning of the project, we had several discussions, and also in the proposal writing, of course, we consider which kind of feedstock will be used. And we also organized workshops throughout the project lifetime. And in one of the workshops, we had a dedicated sessions to talk about feedstocks, which feedstocks that we can use for this kind of processes, that they, of course, they shouldn't compete with food and feed application. It has to be locally available in a reasonable price, in a reasonable distance. So all this has been discussed, and all this has been also reported in one of the workshop outcome from the Glaukos project that you can find on our webpage. But the importance of the feedstock will also come back actually in the LCA analysis that will come in the later stage of the project. So when it comes about upscaling, that which is our main service that we are providing, probably you are familiar with the value of the desk or with this figure that we show all the time, but it's very important to remind you that a lot of the development is actually facing difficulties when it comes to the upscaling, because it requires a lot of investment into not only to the equipment, but also a lot of expertise to do the upscaling. So that's why our company, which is Biobase Europe Pilot Plant, is providing the service for upscaling bioprocessing. And by having these shared facilities, these pilot facilities, it also means that we are reducing the risk for upscaling. So at Biobase Europe Pilot Plant, this is just a few picture to show about our company. This is a multi-purpose shared pilot facility where we are doing upscaling of bioprocesses. We are in operation in 2010. It was founded in 2008, but we are operation since 2010. And you can see that we really increased, because now we have already 180 employees, because it's increasing quite fast. And in the upscaling processes, we can also not upscale technical processes, but we have also all the qualification to work with food grade ingredients that it was not required in Glaukos, but it's also a very important aspect. So when we get the strain from Jülich, from the lab, it traveled all the way to bio-based pilot plant to our team of engineers who started the scaling up of the process at 150 liter scale. And at the end of the project, we scaled up the itaconic acid fermentation into 1,500 liter scale. So we used from the feedstock that we use, it was molasses and glycerol. And you can see a picture that has been posted on our LinkedIn account about the successful upscaling of the itaconic acid fermentation. And the produced product that you can see in the white bag in our engineer's hand, it has been handed over to our partners, Before Plastic, who are working on the polymer. So with this, I will give the floor further.
So good morning. I start from the big back, I think. Let's see. So at Before Plastics, first of all, we are meanwhile involved in several projects that have to do with the design, screening, scaling, and then also upscaling and supplying of novel biopolymeric materials. And when we were writing on the project proposal more than 5 years ago, this was also what we had in mind. It's a whole sequence and it's a whole consortium, of course. But the result is partially there on the table. And we had to start 4 years back in the lab scale. We were dealing with libraries of polymeric materials. And the goal was always to find or to hit new balances in the biodegradability versus the strength of those materials, because that is exactly what you want in the, for instance, fishing gear applications. Then we had to do severe selections. We had losers, we had some maybe winners, and then you have to make them a bit more winning and so on. It's a whole journey. But we got to like a top 3 most promising biopolymers, and those, of course, should then be scaled up, right? So it's a lot of parameters you have to envision. Because, then we were counting grams, and then in the end, half and full kilograms, because this had to be handed over. And a lot of failures, let's say, in the beginning, but then you have to get up again. And in the end, we went to like a plus 30 kilogram for clothing or fashion and for fishing gear prototyping. And the path diverged because it's not an all-in-one solution. It's not that you can make everything from only one biopolymer. So then the new polymers, if you look at them, they should become alternatives on the market, which degrade faster in marine environments and provide also thereby a positive end of life. Because when you think about ghost nets, statistically, it's like 30% of the nets that so far are not coming back to land. And then as a last point, in the meantime, Before Plastics is a young company. We have been running, pioneering also with equipment and so on. And also outside the Glaukos project, we have been installing infrastructure that make it in principle adoptable to upscale it. So that's the last bullet point here. That we are ready to produce. I was writing truckloads. Well, we have to count the tons and how much fit in there and how much is needed. And the oceans are much bigger than the room we are in. So we are also some steps ahead, and that's also something important for the meeting today. That indeed, as the introduction was there, we started a project not to stop here, but there is work to do, and we have a good basis. I see some other years to follow up and to speed up and to bring it to the ocean. So I want to eat Glaukos fish, and so far I did not have it. So challenges is that doing this whole library thing in collaboration with all the partners and all the considerations, there's a lot of checks you have to have green checks in a row, otherwise the innovation cannot fly. The main challenge has been with us that the design and the upscaling and the whole checking list was asking a lot of brain power and good technical hands in our labs. Also, as a young company, we have seen some people moving in and moving out. Young scientists was a breed, even in our company, a breed of a lot of brain power and experimentation, and failures, because there's challenges on the top of the slide. So, let's say the main goal, and I think that's not the foremost, the main goal is to get out of the lab, of course, and that was what we took as a duty on the shoulders, and where we have been reaching out of the lab. And then the last slide for recommendations in the future. To launch successful Glaukos products on the market is a goal. I think we should do that simply, or maybe not so simply, but we should do it and we should learn from it. It's, I think, a wrong idea to wait now and to take another 3, 4, 5 years, because there is something there. You can catch a fish if it's needed. I will catch it myself, so to say, but there is something we can reach out to industry, and we should do that. There should be customers coming up that try the product out. That's the first bullet point. And learn from it, of course. It will not be perfect, right? Secondly is that there is room for improvement, of course, like a Glaukos, I don't know, 2.0, if I can say about that, speak about that. Push the balance further, because it can be stronger and be better degradable, to call both of those. And this might need new scientific efforts, of course, but the basis is good. And then third, the environment to do that might be something like a Glaukos 2 project, a successing project, which will be higher in TRL, clearly, and which can bridge towards the next years, because 5 years have gone fast, but if we are 5 years further in time, we should really be there. I mean what I say, a decade is a long time for the planet to wait for these innovations. So with that, I hand over to Una.
Stefan, do you hear me? That's with
Yeah.
Okay. Good morning, everybody. My name is Professor Gunnar Seidel from Maastricht University.
Okay.
Yes. And our part was the spinning, so the production of fibers and products from the polymers. And you can see some of these things over there. I'll give that to you. And spinning means that we start with granules. As you can see, that's the polymer. And we have different types of polymers, of course, of different molecular structures. And then, the question is always, which structure gives which property? And at the end, you have to try that out. So you do spinning, you melt these polymers, you draw fibers from it, and then you get first filaments. That's such a bobbin of fibers that has been produced, and then we did with different polymer types to find out which is the best, as you can estimate a bit from molecular structures what could be the result, but at the end you have to try. And this is then the textile polymer that is a bit more fluffy. That's the same material, the so-called texture. That's a bit of bulky, wavy structure to make it more comfortable and soft. And at the end, this is a sock produced from this material that is non-toxic.
Can I put it on?
Your feet are small enough for that, please. So what are the exploitable assets? It's spinning processes, and you start with the material. You have to find out how to draw the fibers, which temperatures, which speed, etc., etc. And that's important, as the process has massive influence on the performance of the fibers. Degradability is still a bit a problem. That's a trade-off between, is it degradable or is it toxic in the real environment? And that's a difficult trade-off. That is one thing that we found out. Here you can see spinning. So challenges were to forecast the spinability. So you start with these granules. that's the spinning plant. Here you see the filaments that are running out of the nozzle. They are cooled by air. Then between these so-called girders, these rotating cylinders, you pull the fibers, you draw them to get a tensile strength to make them strong. Yeah, and that you do for all these different recipes with different parameters, more drawing, less drawing, different temperatures to optimize the process to fibers that you really can use for the purpose later on. And then, yeah, you have to work in very small quantities. So first you have some granules and you need some kilograms to really start spinning. So we developed forecast methods to just by lab tests, forecast if it's spinnable or not. That needed a bit of time. Yeah, then we were able to spin all these materials and to optimize them. To produce these demonstrators. What could be recommendations? Yeah, what's really important and on the one hand important, on the other hand challenging, that you always need the complete value-added chain. You saw it started with biology, and then material, and then processing, and then yeah, that's not the end of the game. And it's quite complex, and you need these long value chains, in ideal case in Europe, to cover the whole innovation. Yeah, that makes it difficult and complex, but that's the way to go because there's so many different problems that have to be part of the picture and part of the solution that we really need value-added chain projects and funding schemes. The big question, I think, is do we go to avoidance of persistence of polymers? So do we really need biodegradation, or is one way to reduce persistence? Because that's difficult to get biodegradable things that are non-toxic, but we'll hear more of that later. And we need good development strategies for upscaling because every material innovation begins at very small scale, as you have the granules and the little glass bottle. And you have to forecast how good is that material later. And this upscaling process from some grams of granules to a demonstrator that you have in your hands, that's quite a journey. And therefore, we need better tools to be faster with that. That's my part. And now I hand over the marine toxicology people.
I just forgot to say that everything you have seen, it's not only the polymer, but it's also the coating on the polymer. It's a whole system, and you should balance out the whole system to give it the right functionality. I kind of forgot to say that. It's, for instance, iCodes that has been coming up with a lot of design on the coating qualities.
Good morning, everyone. I'm Professor Ricardo Beiras. I teach marine ecology in the University of Lugo. So perhaps you are wondering what is a marine ecologist doing in Glaukos? So much material science. So I will go straight to the point. We all face this idea, this conception that plastic is bad for marine environment. Okay? But as scientists, we cannot deal with good or bad schemes, but we need to look for scientifically sound methods to assess how bad is a material for marine ecosystems. So that's our main contribution in Glaukos. So which kind of effects may have plastic litter or plastic in marine environments? The first problem that we are all aware is statical nuisance. Why? Because conventional plastics are not biodegradable. So obviously the solution would be to produce plastics that do degrade in the environment. So our role, and I was glad to hear here today that we are missing methods to assess biodegradability in marine environments. Our role was exactly to produce a robust standard to assess biodegradation specifically in marine environments. The second kind of harm that we are all aware is entanglement, ghost fishing. So to solve that problem, we don't need plastic to be biodegradable. It's enough just for that plastic to lose mechanical properties. So marine fauna can get rid of the traps. And the third kind of problem, and it's a problem that is increasingly present in research, is not the physical effects, but the chemical effects, the chemicals that plastics might leach into the environment, into the marine environment. So obviously, European agencies are concerned very specifically about potential endocrine disruption effects of some chemicals used in some plastics. So the solution is to make a priori assessment of these chemicals in order to make sure that industry is using the right chemicals, which are non-toxic. And that is the kind of ecotoxicity test that we can develop, which are quite rapid and are the third element in this assessment, the Glaukos assessment scheme. So only if a polymeric material meets the three requirements, then scientifically we can say that a material is marine friendly, specifically for marine ecosystems. So the first step was biodegradation. So obviously I won't go into details of this, but we did publish a specific method adapting ISO standards to marine conditions, which are very different in terms of nutrient composition, in terms of inocula, and develop this scale of colors, quite handy, to assess marine biodegradability. The second element, no mechanical effects. Okay, so this was more difficult, but we made some progress, taking as an endpoint strength and breakpoint, which is a typical endpoint in material science for different materials, including films, yarns, filaments. So we set up conditions to maximize degradation, specifically again in marine aquariums, and saw the effects on different potential biopolymers using this strength of break at endpoint, and again developing the scheme, the scale of degradability. And the third element is ecotoxicity. So we found out that there is one specific test which is specific, particularly sensitive and quick, which is the sea urchin embryo test. Again, obviously a marine organism. This test takes 48 hours. It has been used for decades in marine science. Actually, Japanese people invented them. It was used in the United States also. And it's a very good screening method because it's quite quick and sensitive. And then we introduced a second step of trying to see at molecular level the expression of genes which are responsible to endocrine disruptors. So we came up with this scheme that we call the Glaukos marine friendly definition for plastics, which is at the same time cost effective. This is very important in terms of duration and costs, but scientifically sound and covers the three main problems that we identify. Challenges ahead, of course, there are. This was just a starting point for many new techniques. So as previous presenters said, obviously we need some more time to develop these methods and to improve standardization. Communication with key stakeholders is very important, and I thank our Italian colleagues to organize events like this, because they're very useful for us scientists who only go to meetings with only scientists and not people that can make decisions. So with this, I give floor to Nick, who will explain, I think, biorecycling.
Me again, hi. So it's interesting. So looking at the Glaukos circle, so we now almost come full circle. We started at a bio-based material. We went through polymerization. We went through spinning, coating, weaving, and we also looked at what happens if these materials do end up in the environment. But I think we can all agree that this should never actually be the goal. So environmental degradation is a last resort option. Now we should always avoid that happening, but of course in real world, this is unavoidable. And so it's good that we have this. But ideally, materials are kept in the circular economy, and we think about recycling of those materials. The challenge here is that these tailored polymers that we are working with are quite complex. So we're looking for new functionalities to add on to existing demands. And so what we typically do is we add monomers, we add coatings, we add processing steps that make these materials more complex. And so this makes them very difficult to use traditional recycling. Mechanical recycling of a coated fishing net is just not possible. And so because we look at biodegradability, we look at reducing persistence in the environment, we thought, okay, can we not leverage this to also use biorecycling? So if we design a polymer to be more easily degraded in biological systems, can we also use a technical biological system, so biotechnology, to recycle these polymers? So this is what we tried in this package. So we look at starting with a new polymer, we depolymerize it, we bring it back to the monomeric form. And this then can be done using enzymes, which we did together with Novozymes. We look for new enzymes like nylonases, esterases that break down these polymers. We also enhance that by chemical methods to make sure that it's up to industrial standards. Then we have this dissolved plastic again, this monomer mixture. And because it is rather complex, what we do is we feed it to microbes. So we use it as a new carbon source, a kind of third generation carbon source for biotechnology. And this is not trivial. These are not sugars that are coming out of these polymers. And so we engineer bacteria that can then metabolize these plastic soups that we can then use as a carbon source to start thinking about upcycling. So turning this plastic into a completely new and even benign material. Now, so that was the goal that we set out to achieve. What we achieved, in fact, was new enzymes that we found, so-called nylonases, that can break the amide bonds in these polymers. So this is one important step into complete depolymerization. We engineered microbes by deep metabolic engineering that can then metabolize the plastic monomers. And then we couple that all together in a process where we then demonstrate the degradation of the polymers back into the monomers. So we take an actual polymer and we dissolve it in water, basically, depolymerize it. And then we feed that depolymerized material to our microbes to produce, in this case, polyhydroxyalkanoates. And actually, polyhydroxyalkanoates are for Ricardo the positive control of a polymer that is benign, that is biodegradable. And so those were the project outcomes. I think what I learned from Glaukos, and I was very happy that Glaukos took this entire circle where we don't just look at how can we make a new polymer, but we start with the end in mind as well. So we design a new polymer along with the recycling process. And we can tune the two to each other. I think this is very exciting moving forward. We need to still screen for more and more efficient plastic degrading enzymes if we want to make this biorecycling really industrially viable. And we can now, with these engineered microbes, once we have microbes that grow on plastic monomers, we can use this plastic as a feedstock for biotechnology. Of course, now the sky is the limit, because everything we can make with biotechnology from sugar-based substrates, we can then also make from plastic-based substrates. So we can think about a kind of feedstock flexible biorefinery, which maybe in the summer uses agricultural side streams, in the winter uses plastics or something like that. Now, so this is then looking towards the future. And with that, I think we went through the entire circle here. So then I can hand over to the middle part, which is, of course, where everything comes together.
Nick. So hi, I'm Josephine Prativi from Qantas. And in the Glaukos project, we've been working on going beyond traditional LCAs and really have a holistic environmental sustainability assessment. So, well, traditionally, sustainability has been focusing on climate change
And this could lead to a sustainability tunnel vision, because if you only focus on one certain indicator, you might miss trade-offs in other ones. And this is why we are using LCA for the sustainability assessment. And what's good with LCA is that we take into account the whole life cycle of the product, like the circle we saw, but also it's a multi-indicator approach. So we also take into account other indicators such as land use, ecosystems, biodiversity. And the problem is, so LCA is very, let's say, comprehensive, but it's still missing some elements such as the plastic leakage, so macroplastic and microplastic release, but also circularity. So what we've done in the Glaukos project is to combine 3 complementary sustainability assessments. So we have the LCA in red, plastic leakage and material circularity, and we've integrated this into a holistic sustainability assessment. And this holistic sustainability assessment allows to have a fair comparison with conventional products, but also to identify trade-offs and identify hotspots and areas for improvement. So when integrating these 3 sustainability assessments, we also seen that when focusing on different performance factors, such as the bio-based feedstock or the recyclability, biodegradability or durability, we have different, let's say, influences on the assessment. So what we're using, so we have LCA based on the product environmental footprint method, circularity based on the material circularity indicator from the Ellen MacArthur Foundation, and plastic leakage based on the plastic leakage project developed by Qantas. And for the plastic leakage, we just have a difference. We have to distinguish the amount of plastic leaked, but also the impact of this plastic that's leaked and the persistence of it. Now, for the impact, the methodology was not ready yet at the end of this project. So this is why there's still some areas which are not available. But we've allowed to identify, identified what are that there are different, let's say, connections between the performance factors and the assessment. So we see that for the bio-based feedstock, this has a high relevance for LCA because we take into account the natural systems, and also for circularity, because the amount of feedstock from bio-based, so from sustained production, has a high relevance on the result. But for plastic leakage, this is low because it's more focused on the end of life. Whereas for recyclability, for LCA, it has a low to medium relevance, but for circularity and plastic leakage, it has a high relevance because these indicators are more focused on the end of life. So high recyclability would allow to get a good circularity result and a low plastic leakage impact. In terms of biodegradability, so for LCA, it has a low relevance for the assessment and circularity as well, and also on the plastic amount, but probably it has a high relevance for the impact. It's just that since this methodology hasn't been fully developed yet, it's difficult to quantify this. And I've put also a star because biodegradability and durability we've seen in this project are quite linked. So there's a trade-off between these 2 performance factors. So if the material is very biodegradable, which leads it to make it less durable, then it has it would have an influence on the LCA because then we would have a lower durability. And with durability, this has a high, so durability, like in terms of the lifetime of the product, this has a high relevance for the LCA and the circularity, but again, low on the plastic leakage, unless this affects also the amount of mismanaged waste, because if consumers perceive the product to be more durable, then they would keep the product for longer, and this would be going less into landfill, for example. But this is, less of the quantitative aspects of the assessment. So here we have an overview of the different performance factors and how they are relevant for assessment. And in terms of future research agenda, so with the assessment that we've done, we would recommend to develop products which have enhanced durability compared to conventional products, and also promote the practices that extend product use, such as increase perceived consumer value, and also increase the amount of sustainable feedstock. So moving away from primary production of feedstock and using more feedstock from secondary and tertiary production, and also doing more research and development on polymers, modification, spinning techniques, and coatings that would reduce fiber shedding and material wear to decrease plastic leakage. And of course, continue carrying out holistic sustainability assessments to really identify trade-offs between the different indicators.
Okay, so good morning. I'm Selenia Marinelli, and together with Susanna and Luis, we are from FDA Media Research. And specifically in Glaukos, we were responsible for the communication dissemination, but also the stakeholder engagement activities. So now we will present the project to policy format that we implemented in the project throughout different workshops that we organized, and also the methodology that we implemented in the project for the stakeholder engagement. So here you can have an overview on the different activities that we implemented in the three, let's say, main phases of the Glaukos project. Of course, depending on the stage of the project, we fine-tuned and restructured, redesigned our strategy. So starting from simply raising awareness on our project among the relevant communities of stakeholders, trying also to collect specific information to inform our research, we went through the second stage of the stakeholder engagement strategy, in which we tried also to stimulate debates around pressing challenges that are relevant not only for Glaukos research, but also for the entire community of stakeholders and projects which are trying to address similar challenges. And so in the final stage, we focused on the exploitation of our results, and we also focused on the marine-friendly biopolymers debate. So in the last, let's say, workshops that we organized, we really debate around how to define and how to fine-tune our definition that we agreed on, and to validate also the methodology that our partners from Uvigo before presented. And here you can see an overview on the different 10 workshops that we organized during the duration of the project. And we finally were able to engage more than 400 stakeholders in total. And considering that from the grant agreement, we were supposed to only have 40. So we are really proud of the result that we were able to achieve. So in the project, we implemented this format that we called project to policy. And the main objectives were precisely to shorten the gap between projects and policies, and to facilitate the exploitation of project results, and also to inform and recommend future policies. So this was a key, let's say, step in order to also try to structure the discussion around relevant challenges that was proposed by policymakers, as well as to map and involve also the projects that were trying to address these specific challenges. And finally, we try to stimulate a structured discussion around these topics in order to generate actionable knowledge. So something that could really be handed over from the different stakeholders in order to produce concrete actions in the different domains. One of the main results that we were able to retrieve from all these stakeholder engagement activities were this Glaukos multidimensional model. And basically here from the different stakeholder engagement workshop that we organized, we collected many inputs on what are the main pressing environmental challenges that we need to be, that we need to address also to unlock the potential of bio-based and biodegradable plastics. So here in the scheme, you can see the different challenges connected to the ecosystem creation. For example, the system perspective, so LCA or bio-based versus conventional plastics, raising awareness, stakeholder engagement and collaboration and coordination among projects and initiatives, the project contribution also to industrial and policy agendas. And on the other hand, we have specific technical challenges, so safe and sustainable by design, purchase and usage, and finally, of course, the end-of-life solutions. So this multidimensional model was also used as a way to keep on engaging actively stakeholders also during the last CBJU Stakeholder Forum. In fact, we printed an interactive poster in which the different stakeholders recognizing themselves through the different colors of some dot that we asked them to vote what were the main, let's say, prioritized challenges according to them. So it was also interesting to see how the different stakeholders perceive the different challenges and how they voted in order to prioritize them.
So in terms of overall results and recommendation from our stakeholder engagement activities, so first of all, we recommend to always push a lot in having the stakeholders involved in all the processes. So we had the stakeholders in the consortium, but also we continuously engage them for the reasons that Selenia said. And the workshop played a crucial role in awareness raising, not only externally, but also internally in the companies involved and through the networks of our stakeholders. And then we were very active in stimulating the debate around bio-based and biodegradable plastics. Therefore, we gathered valuable insights, and then, of course, this was used by us to drive our research, but also by other projects and hopefully by some policies. And so Glaukos was positioned as a key player and was also recognized by the Mission Ocean and Waters as one of the signatories of the charter, but also as one of the case studies, for instance, for the Blue Mission Med project. And we facilitated the knowledge exchange among different projects, but also among stakeholders and researchers. And finally, we were able to really provide all this information package. So not only one project to the policymakers, but rather we had in a certain moment 40 different projects all together providing single indication to the policymakers. And this is a very good way to go because, of course, you maximize the impact and the interest. And so again, we want to highlight that even the RIA and the innovation action should be the stakeholder engagement activity should be very central, and also the educational activity in terms of awareness and information in order to make sure that our results are really exploitable, are really relevant for the stakeholders. Okay, we are done. I think I just want to show you this interactive. You remember, you have seen everywhere this interactive wheel. This is a very good way to understand the overall picture of the project. And what we did, and this we will find in our website, is per each step of the wheel, we created some videos that we shooted inside the labs, so you can really put your nose inside of the labs and understand exactly point by point how our research works through the voices of our speakers, of our participants. Okay, so
now we can go to the round table with our Glaukos industrial partners. So I invite Kun from IPOT to come here. And I don't know, from BSI, I don't see anyone. So, yeah, Thomas, okay. I couldn't see you, sorry. So Thomas from BSI. And then we have Philippe from Eurocard. And we have Anton from Nexus Fiber. So this is going to be like an open debate and around our industrial stakeholders. We prepared the three main questions, and of course, we are also open to additional questions or contribution from the audience. So yeah, we can start from the first one.
Yeah, so the first one is how does the participation in projects like Glaukos raise awareness and stimulate the market debate on this topic? So we can start maybe with Kun. Okay.
Can have everybody see the question because beautiful men are blocking it. Actually, this is our final gathering, and it's been an honor. It's a pleasure to be part of Glaukos from the start, actually, because Stefan and myself, we were at the baptism of this project, first refused by the policymakers, but we get a second session, and then it was accepted. Now, to answer the question is that over these years, I feel that I became an ambassador of Glaukos because our market, our end users, I-codes providing overlay finishes and coatings to rope and netting manufacturers, so really in the field. 4 years ago, bio-based, biodegradability, there's no definition. What are you guys going to do? You've been talking for years and years that you want to have your coatings and finishes as long as possible on our subjects. And now you're saying they're going to be biodegrade. When? So that was for us a very difficult one. And with the partners of Glaukos, actually we grew into that microplastics and nanoparticles, those will be important for us. So how to bring the awareness to the market is to be more, I would say, technical equipped within the stakeholder meeting we had within our consortium, which was excellent because we have so much technology in this partnership that we can provide it to our end users and telling, hey guys, we believe in it. And yes, not 100% because that's impossible, but step by step, bringing it into the market to support the climate change to get a better planet.
And then we had two major associations, so one from all the equipment around the fishing world, let's say, because it's not only fishing gear, and the sport industry. So let's start with the closest one. So yes, be aside.
It's a pleasure to be here, to be part of this Glaukos project. Like Susanna just said, I'm from the German Sporting Goods Industry Association, which means we were the partner for the apparel, textile, clothing input to really bring the perspective of these brands and manufacturers who use the polymers and fibers into their products, and then obviously bring the products on the market, and everybody of you uses them on a daily basis. So I think it's a very important project because textile innovation and the exchange is really an essential element, because to show these companies new perspectives, new solutions, new approaches, and have it in a format like in Glaukos, where all the different stakeholders are together, can raise their concerns, bring in their perspective, and then work on a solution. Because from our experience, the brands are very interested in new approaches. They want to make better products. They want to make sustainable products, and are guided by the technological development of the market, also what the consumers expect from them. And so it's a learning process. And I think it's very, very vital to raise this awareness, to slowly push the market forward and into the right direction.
Thanks. So what about the fishing domain?
Yes, thank you. I will say that most likely when 5 years ago, we all were all of a sudden confronted with the single-use plastics directive. Many of our members were wondering what's going to happen now. What are they going to invent now in Brussels? So I must admit that many discussions which were held together with the Commission created a much more open framework in which we could indeed define what would be important for our sector to continue and to come to something which will be more acceptable. Still, we had questions. How is this project going to come to an end? And I must admit, I was one of the first ones when starting, having doubts whether we ever would come with something which would be acceptable. And I must admit that when I see today where we are, with all the efforts which have been made, it is really amazing. I didn't expect it, honestly. So there is a good result, which is already now available. Today, we're facing that with the maritime sector. Fishing nets, fishing ropes, that's fairly important, obviously in the framework of the single-use plastic directive. But it's not the only one. I can already sense that there will be a very good possibility for the agricultural market, which is also in the hands of Eurocourt, to try to come to a better solution, always in the framework of what potentially could be done for the Green Deal. But it'll be a major invitation towards all of our members to participate now more actively, now that something is available. So let's try to do it ourselves now.
Something that was very interesting that emerged during one of the workshops that we did with the stakeholders was that one of your members said after participating in this project, we now are aware and we now invest internally the 5% of our budget towards these topics. That was not the case before Glaukos. So this is something that is very important from a company point of view.
Yes. I'm from Nexus Fibers. We are producer of industrial polyamide 6 yarn. They're used for nets and ropes for fishing and fish farming. And we are really, it's hardly to compete nowadays with Asian market with this yarn, that we are looking for some new opportunities. It means to have some specialties in Europe, because our productions are located in Europe, Slovakia and Latvia, to have some special product for sustainable product. And we are here for the upscaling and to make the industrialization of such polymer and to bring it in the ocean.
Bring it back from the ocean.
Okay, great. So let's go to the second question.
Okay, before going to the second question, which is on marine-friendly biopolymer, let's resume the definition that we agreed upon. How can we define the biopolymer marine-friendly? So basically, we have these three main characteristics, and this polymer, in order to be marine-friendly, should be eventually mineralized by environmental microorganisms to avoid its persistence in the environment. It needs to be mechanically degradable in the marine environment to avoid consequences as ghost fishing or obstruction of digestive tract of marine species, among others. And finally, it needs to be innocuous for marine organisms and their early life stages to avoid ecotoxicity. So that said, I would like to ask to my colleagues, how can marine-friendly conceptual framework that we just defined in the project can be integrated in your present, but also in the future sustainability plans of your associations or companies?
Well, it's quite complex question because you can imagine that working with this type or with the current type of products that has been years and years of research, of development, of finding the right solution in order for the specific characteristic which was searched for in order to have decent material. So today we're there. Obviously, what needs to be done now is to find the way to make it biodegradable or I don't know what, but anyway, make it more acceptable in order to come to a solution which for everyone will be acceptable much more than it currently is. But that's still quite a long way to go.
So Kun was one of the main pusher of the question of marine friendly. So let's go to you.
Actually, we during those 4 years we evolved, and we had difficulty with the bio whatever. And the end users, the people who are working with their nets and with the ropes used in maritime environment, like Philip is indicating, they've been studying on a concept for many years to have the best construction, to have the best efficiency in fishing, to have the best sustainable possibility of getting actually the fish on shore. Now we are here and saying, hey guys, wrong. That's very difficult to indicate to hunters in wild oceans to say you're wrong. No, they're survivals. Yeah. Sustainability for them is actually to survive 3 months out there. Now, what we can do with marine friendly approach is that, hey guys, please don't throw the net overboard. Collect it, bring it back. That's one step. If we would say now 100% of this fiber, what you see here, is biodegradable, they will say, okay, good, net is at its life end, so I throw it overboard because it will biodegrade within 10 years, 20 years. So problem solved. 2 tons less weight, 2 tons more fish. Well, wrong here. So marine friendly for us is a concept in which we can provide the same strength, more or less, perhaps a little give-in, having the right bio-based coatings, which is important without losing the strength there as well, but it will take a lot of convincing. The market actually, as we discussed it already, is not ready. Why? Because it's not mandatory. I'm the chairman of TC466, sent Senelec on sustainability, yes, circularity and recyclability of fishing gear, and aquaculture equipment, where we provide then the standardization, how you should treat your equipment. It will be in place on 2025, but it's not mandatory. So we can be ambassadors. We can be like Stefan is indicating, come on, we have it, buy it. It's marine friendly. Yes, if we can have some support from the policymakers and saying, yeah, in the Netherlands it will be like this, in Belgium like that, in France like this. That's not uniform. What we try to do now, even with Glaukos, being out there, talking to those people, stakeholder meetings, please, let's do it all together in the same way. And then marine friendly as
So we can stay in this world and then we will go in the sport.
So we realized during the project that it's hardly to achieve the same mechanical properties of the yarn and to have this biodegradable and bio-based formula inside. It is a big challenge to be on the same model. I personally think it's not impossible, but very hardly possible. That means we need to looking for some policy to push the producer of the fisher to buy some biodegradable nets, even that have not so high mechanical properties as the standard material, but it's still reliable to fishing.
So when we designed the workshop with your members about, and we started to discuss about the question of biodegradability, you remember you said, let's be careful because they are very resistant. So, but it was very surprising how they reacted positively to this question of marine friendly and how they came back finally to some concept, but through another way, you know. So, Thomas.
We heard from the fishing parts, fishing nets experience, and I think textile is in some aspects different because in the best case, textiles shouldn't be nowhere near the ocean or in the ocean, and the whole concept of biopolymers and biodegradable material is quite a hot topic. There are some concerns, and I think it can be used as a building block in a sustainability strategy. There are several approaches and several things the brands are trying. It seems sustainability is a really wide field, and you can do a lot of different things. Some design their products with circularity in mind, some so that they can be used with a really long life. Some use recycled materials, some use natural materials, bio-based materials. So it's a very wide field, wide spectrum, and I think there needs still some convincing and awareness and more information and practical information to show it's viable. It's can be an alternative. It has the potential to compete with polyester, with recycled polyester, with all these things. And I think there is still a way to go, but we'll see.
Thanks. So we go to the last question, and then
So according to you, what were the main lessons you learned during the project? So some of them maybe already came up during the debate, but maybe you can focus just on some of them.
I'll get to someone else first.
A lot of things. For example, from which material we can produce some precursors of monomers for the polymers, like itaconic acid. It was new for me, and how we can make some tests in the ocean to see how to adjust the marine-friendly polymers. That's the main that I learned from the project.
First of all, I would like to say it was very interesting for me to see when I experience this world of biopolymers and ecotoxicity research. It's quite different from what I normally do in my daily life in the Sporting Goods Association. But I think it's really fascinating. And we heard a lot about the process, what can be done, what can't be done. It's quite difficult. There is iteration, there's failure, there's success. And I think what really is fundamental is the wheel. We saw several times today that we look at the whole circle, the whole life cycle, and not just some parts of it, but all of it. And this is something I think also was mentioned earlier. The project may be at an end, but we are nowhere near the finish line. We really just starting out. We have a prototype, but we have to see, push it further. We need more engagement, more action, more research, and to really push it on the market and to show that it's viable. And I think this is something that is the main takeaway.
Thank you. As you introduce actually my thinking. First of all, what we learned, and I think if we talk about we, not just me, but the Glaukos members, is that the European calls have their meaning. It's a pleasure to have international specialists at the table. We were a little unfortunate with COVID. Yeah? So the lesson we learned is that even with COVID, we found means together by Zoom, Teams, and intermediate action. Why? Because we believe, and that's very important, all those people together, we believe in the future of Glaukos. Yeah? And you indicated already, and I said it yesterday, this is just the beginning. We need support from Europe again for Glaukos 2.0. Why? We have the backbones, we have the scientific approach. Now the next step is how to profile a prototype in the market. If you saw this, and I saw people pulling and saying, oh, the rope, oh, it's strong. It's rather strong, yeah? If you have a nylon PA6 rope, it's still different. But we are there. I think with this team, we can move it forward, and the stakeholders, we have their attention. If we continue having their attention, we will have business. Sorry to say, but the lesson for us then, as a company, it should actually bring business. Not just projects and wow, and we're glad, but yeah, we'll put it in the drawer. No. It should come in the market. And that's now in 2024 that we will try to do that. 2025, Stefan indicated already, he will go and make a net and fish himself. Do it, my friend. But I think you will be on your own in a small lake. I will join you. Small fish. Yeah. But the start is made, and yes, it takes time. 4 years. Wow. What happened 4 years ago? I don't even know. I know we had our meetings and it grew. And the lesson out of this is that it is always to do with people. And the people make a project successful or unsuccessful. And I'm proud to be part of a successful one.
If I can end the main takeaway I take from this, well, very much goes into the same direction. If we can come to such a result, knowing the great, how could I say, the doubts I had myself at the start, and when we come to such a result, if we can do it in this way with such a tremendous bunch of people sitting all together and reflecting on the different problems which are raised, we should be able to do something else as well. So I have already a few ideas in mind, for which I will come and knock on the door of the Commission, obviously, as soon as possible, so that we can continue in the same way.
Thank you. And maybe there are also the other partners that would like to share their lessons learned in the project. Maybe. Who wants to? I'm looking at Stefan, but I don't know if you want to.
Just a very brief comment, because I don't think there is a problem that the material obviously cannot be biodegradable and resistant at the same time, because fishing gear is a quite complex thing with many parts. So obviously the net is to be very resistant, so probably it doesn't make sense to make biodegradable nets. But other parts of the fishing gears that get lost very quickly, for example, lorry ropes or the buoys to float, and these parts might have sense to have biodegradable. And it's the same for many other plastic objects, depending on the lifespan of the object. Ideally, the longer the lifespan, the less the ecological impact. So that's the first rank in environmental protection. But for items that are short-lived, for those specific items, I think biodegradability is very interesting ecologically and achievable.
Any other that would like to share? Maybe?
So I can just say, as one of the fewer academic partners in the project, I have to say I was very happy. So in this CBE projects, I think we were 3 academic partners and many more commercial partners. And to see the drive and the willingness from these companies to become more sustainable and to become more bio-based, and there is a definite push there and definite interest in doing this. And I was very pleasantly surprised by that, because it's I think not given that it's easy to make money, but also to make money in a sustainable and responsible way is at the forefront here. And I was very, very positively surprised about it. Chapeau to this.
Thanks. So maybe we can have some questions from the experts, the policy makers. Do you want someone would like to ask to say something? Thomas?
Thank you very much. I have just, because I was not really following the project, so I'm really curious about this engagement of stakeholders. I think it was very, very good. I mean, so many meetings and people engaged. And I wonder about the comments about the follow-up and on the policy level, in fact. So, for instance, if there was any engagement that you had with, for instance, DG Mare in the commission, or because I would imagine they are also not maybe national authorities, I think, are very important also, how to see, well, the voluntary versus mandatory is always a tricky question. Of course, it would be good to have this push from the policy side, but of course, then the solutions need to be improved and made tested and so on. So it is I guess a question.
Yes.
But I just wonder about this.
Well, this project to policy was an interesting format also, because we really experimented it, and we started from some key questions from policy makers, from policy officers, from several DGs. I think I think all the DGs.
Yeah, all the DGs.
And
of them representing different DGs.
And so then we went back to the projects. We asked the questions, and then we organized additional 2 workshops with first one with the projects, and then the second one with the policy makers to kind of bring back the contents. So it's a flow that goes from some specific question to the project and then back to the policymaker. So this format can be nicely replicated, and this is also something that we are doing, for instance, in Blue Mission Med, that is a Mission Ocean and Waters project. So we implement those formats, and this is a good way to go. Of course, you need to do your part, because I have to say that sometimes it's not very easy to have you on board. So when we and this is the reason why we are grouping many projects, so you don't have to run like crazy for one single project, but rather you can go for many projects and also use it online. But I think this is a very good replicable idea and format. Yes. Any other questions?
Also from the online participants?
I wrote there's just a link from Before Plastic that says that he is really proud of us.
Okay, so I don't know what time is. I think we are perfectly in time, even before.
Even early, yeah. Okay.
So maybe I can give.
Maybe that.
Okay, sorry, dear. I didn't see you. And it's strange that I didn't see you.
I was sitting. So. A very good project, by the way. Very nice done. You had a look to the challenges in the past, but I was also like to ask kind of a last question. Ask you, how do you see the future? What you really did to develop this, to bring this to the market? So what are the missing elements? What would be the ideal situation to for the next steps?
Okay, I think that maybe who wants to answer? Maybe Stefan.
I think I will partially repeat what I heard also from that Glaukos can still die, but the foundation that we have after 4 years, it's quite amazing. Also, if you see 5 years ago how the ideas were created and what we have now, it's a room full of people that know each other, that have a foundation. But there is a step to make, and it's a bit like a shifted TRL prototype. Certainly, I heard Thomas saying something like, it is the right way anyway. So we should tempt the early adopters, as we call them in the market, to try it out and to learn from it. And we need still a context for this. I mean, Glaukos can still die if you leave the room and we just say hello once in a while to each other and there is no framework to follow it up, it might fade away again. I don't know if that's fully answering, but I think we need the next phase. But I have the very strong belief that we will get somewhere and that I don't know, Europe will have a leading role in this.
Also the application fields, maybe the agriculture, so even enlarging the application fields.
As you could see underneath, one of the partners is actually a fishing nets and rope manufacturer company Van Belen in the Netherlands. Unfortunately, until last week, we were not able to come up with this. Yeah. This is actually for the maritime industry key, that we can prove that a fiber can actually be braided afterwards and net can be made out of it. She's still in the waiting room, and I think she will be following as well today. This is actually the future. If you're asking for the future, is that we need tangible products to show to the industry, hey guys, and like you are indicating, Ricardo, it is important that in the future we can tell them, yes, a full fishing net, 100% biodegradable, forget it. We're not aiming for that. We're aiming for some durable items which actually are lasting 1 year, 2 years. And we have those in maritime. Even in leisure sector, yeah. If we're talking about clothing, if you're talking about sailing, you talk about yachting, climbing, people throw ropes everywhere around. You say like, come on guys. If they are already nanoparticles biodegradable, it's a start. But we want to continue. I don't think Glaukos is that. It's a god. He never dies.
Question, Dirk? Now I saw you.
It's not a question, but follow up. So I think, you know, that big we have at the moment, 5 years ago, it was different. We have more than 300, 320, I think, companies as members at the moment. We will organize also more webinars which are more market oriented. And in September on the program, we have a specific webinar on sustainable textiles. And we have more and more, by the way, what we call internally brand owners. So companies that bring bio-based products on the market from different areas, including textile. So we will, after what I have seen now, we will invite also Europeans to give a presentation during unions webinar. So this can also create, you know, new networks, new opportunities. Thank you.
Great, many thanks.
Thank you. Well, a brief introduction. I'm from a sister unit of Thomas and from the unit from the same DG, RTD, from the unit on bioeconomy and food systems. So from the policy point of view, I want to talk a bit about the future and the near future. In the near future, we are kind of subcontracting the JRC, the Joint Research Center, who normally help us on the shaping policy. And they will organize a workshop in June on biotextiles. So hopefully some of you will be there, or I'll tell them to invite some of you, as I've seen really promising work here. Then on the well, it's not that near future, but by the end of next year, we are supposed to update. They want to publish the update of the bioeconomy strategy. And well, it's not on my hands only, but I hope textiles will have will focus more on textiles than before. And then, well, as you might saw in the progress report published in 2022 on the bioeconomy strategy, one of the missing points was on consumption and production. So for sure, we will focus on that. And well, and that's it. We might launch a stakeholder consultation by the end of this year. So well, there is work ongoing. I cannot promise mandatory targets. This is well, a cross-cutting policy. A lot of DGs are involved, and difficult really to. Well, congratulations,
I just want to highlight the fact that all the stakeholder engagement activities were also possible thanks to the European Bioeconomy Network. That is a network of now 160 projects. And this is the reason why all the projects are always coming. So even the European Bioeconomy Network needs some support.
Yes, maybe to add also what I hinted very briefly in my presentation. Of course, there will be also further opportunities in Horizon, different parts of different clusters. So, for instance, cluster 4, we know that there is a preparation about the partnership on textiles, which is to be, of course, defined, because this is still in the process, but it could be an opportunity to be included. It is not necessarily focused on bio-based materials, but of course, circularity of textiles is a topic that is very high on the agenda, and we also have many activities on the social engagement and the consumption, as Noah said, and this is going to stay for sure in the pipeline. So there will be opportunities in this, and of course, CBE partnership itself also keeps very high, the attention on circularity, and well, it is the title of this partnership even. So I think there is more to come for sure. Thank you, and again, congratulations. I think it's very good projects. Thank you.
I don't see anybody else. Okay, so I give the floor to Nela, that is always our super supporter in all the activities.
Super supporter. It looks like sounds like a football match. Let me see how I organize myself, because normally when I speak with my body, my arms. So I'm not accustomed to keeping this thing in front of my face, but I hate to show you my back.
It's okay.
I can stay there.
This beautiful.
You can see there is another chair.
Oh, there's an additional chair.
No, I don't like to sit. I'm sitting up here. You know what I'm going to try and limit myself to just a few remarks. This project responds to the topic EBI 2019.SO3.R9, which means that we wrote this topic in 2018, and this project was in the annual work program of 2019, therefore it was launched in 2019. The project didn't start until 2020. So you see, from when BIC started in 2012, we started writing annual work programs in 2014. In the beginning, marine and aquatic and fisheries were not on the table. They were not there. Everybody else was, but not marine. But as we progressed, the screaming sounds from this world for us to BIC and EBIJU starting to go through a ceiling. And when we finished this project, this topic, which was actually only focusing on fiber and additives, not on fisheries, but then we realized it could apply. So when it was out there, we got questions: can it apply to fisheries? We said yes. So we were so happy to see that Glaukos was the one that got the grant. Because then all of a sudden we saw, yeah, you see, this topic is so wide, it could well be applied in this world. And we were in the process then to bring marine and aquatic on board, not only from a perspective of using these resources, because we were always talking about agro, forest, etc., waste, but we didn't use we're not accustomed to talk about resource from marine and aquatic. So we started to think about that. But also we were looking, this picture that you showed about entrapment and all sorts of, it makes your heart cry, if not your whole face and eyes. And we realized that we had to do something about using and see marine aquatic also as a sector where we can apply these bio-based products. So we were extremely happy with this project. And listening to the presentation, I learned a lot of things. Among others, I learned about biorecycling. I know about chemical recycling. As a chemist, but this is mind-boggling. If we could use this to create engineered enzymes to eat plastics instead of sugars, who would have thought about that, a few years ago? So the things that are happening in CBEJU as it started happening in BBIJU are limitless. But what I like about this project is that it brought so much more than it intended to bring. First of all, I heard, I believe it was you said that you were so happy that so many industry partners participated. Well, you see, R was you. R stands for RIA, a RIA project. And way back when we were writing topics for RIA, we were concerned that the industry was not really participating in RIA. They would consider RIA, let the academics do this sort of stuff. We're in for shares. But we wanted to convince them to get there, and we succeeded in this project, bringing in so many industry actors to participate. And this always brings a hell of a added value to any of these projects. But what I particularly like about this project is that wheel there. You call it the holistic approach. I hear the lady in the back there talk about holistic assessment, sustainability assessment. We love this because more and more we are into this process to almost force down the systemic thinking among us, among everything that we do, because everything we do somewhere will have an impact somewhere else. And by putting it in your face as a circle, it forces down the systemic thinking. And this is what we are now trying to do. And it includes from the feedstock all the way to bring it back and keeping the recycling and apply this design by recycling system. And the other thing I like about this, I hear so many people say, all these changes, it's difficult. We got to persist. We have no choice. With bio-based sustainable products and solutions, we are heading towards a tsunami of changes. And if anything is easy and good for people, and that is, they don't want to change. People don't want to change. Why should I remove? Why I get out of my, my cocoon where I feel very good? But we must continue to, otherwise we will not succeed. So there are so many principles that came out of this project that we, with our partners in CBJ, will use in other projects, because we need to learn from the things that we get from these projects and apply them everywhere. So congratulations. And I hear Dirk, the big boss, saying that he's going to invite you is in the upcoming webinar. This is true because textiles, fibers, and the sustainability, sustainable products for these fields continue to be important. They are still there in the multi-annual program, in trajectory focusing on products. It will never go away. So congratulations, and we'll looking at using you. Thank you.
Thanks everybody. And I don't know if Simona, you want to say just something as PO, because you are basically our father. You're the one that will take the honor.
Responsibility. No, I thank you all for both for the presentation and the discussion. I think we learned a lot about the development of the project. We learned that also from unexpected changes in the work that you've planned, you've learned how to cope with that and how to arrive to something that can be prototyped and can be scaled up with success. So I think that is what is more important, because as most of you have said, now we need to step forward. And that is stepping forward is needed solid grounds. Otherwise, everyone is going to fail. As CBJU, we have topics on some application. For example, there is in the work program that is up there this year an innovation action about biodegradability in soil application. So that is a different sector, but the scope is pretty much adjacent from what you've done, and probably the discussion that you are fueling will lead further opportunities for the future. So I think this is a very positive example of how to approach a sector that is evolving like this one. Thank you.
And so now we should have lunch. I will try to push it a little bit because we were on time, and this is something we are really proud of. No, we are 6 minutes beyond, so we can make a dance or something for 6 minutes. I will go there, so take a chance to approach the partners, ask things, and I will see you. Yeah. And to see the prototype, to touch, feel, don't eat. Up to now, because it's not toxic. And
also thanks to the participants. So thanks also from the online participants. And we have also comments from here. Many congratulations. And well done, congratulations to the outcomes. I wish us all the best that the project will somehow continue. This will change the industry. The important thing is the stakeholders from industry show up and spread the word. Thanks for the massive work done. And then we have also another congratulations and our company, so from Cesare Cittadini, our company has a long tradition of working on continuous innovation from our products, so we would like to be involved in a venture future partnership. And we finally have Hendrik, who is commenting that he's really enthusiastic about this results obtained, and best wishes and to all of us for the expected long-term mission to realize the transformation of fishing gear industry. So thanks also to our online participants for your engagement. Bye. Thank you.